possible to start a fire using eyeglasses. What do you think?
Yeah.
That X-Men dude did it, right?
Which one?
I don't know his name.
Cyclops?
Yeah, Cyclops. The guy with the glasses.
Well, I think he uses a different mechanism.
He just has lasers
But-
coming out of his eyes 24/7.
Yeah.
It's just to control it.
He's gonna block him with black stuff.
So it sounded like most people said yes, and that is the correct answer. And this would be the point where I would say, well, let's go outside and let's give it a try. But you need the sun for that to occur. And the sun is currently behind the clouds. So that is not going to work.
Can we
But,
go out there when it's sunny and do it?
Yeah.
yes.
Yeah.
Did I hear you say that you want to start a fire at school?
Yeah, just like I did in grade school. You'll hear about that story later. Okay,
The arsonist.
so it's weird. Fire kind of follows me around in my life.
And
I don't know why.
Arson.
But I've got at least 6 stories, and you'll hear them like every day between now and a week from now. Okay, I'll try to do one a day. If we've got time to end the class, I'll tell you what.
Flame.
Oh my god.
What? Not quite that big.
When you play
It's more of a
basketball-
subliminal fire that follows me
When
around.
you play basketball, you catch fire.
You know it.
No, yeah, I
answer
remember.
just
I remember
yes.
that game. Like it was last. I mean, you were in it like both years, but like especially last year. Like, yeah, the seniors got it, and then like you dropped like 12 in like 4 minutes, and just like taking it to the basket every time. I'm like, dude, what is Miles doing?
That was fun.
You
I hope we-
crazy
He's
last
going
year.
insane.
I hope we get a chance to do that this year. That was a good
We're
time.
killing you guys.
Oh, I forgot how many
Okay.
basketball.
Science. How many of you guys are nearsighted so you can see things close up but not far away?
I don't know.
Most people.
I'm blind.
Okay. So, what I would do is we'd go outside and we'd say, okay, let's use one of your glasses and we'll see if we can start a fire using your glasses. And what would happen is I'd have like an old piece of newspaper and I would take off your glasses like this and the sun would shine through and you would notice that the light rays are not like coming together anywhere. They're kind of spreading out. And that's what's happening if you are nearsighted like me and like most of the people in the world. Your eyes are too strong. And so what's happening is, like, you guys know about something called the retina, right?
Yeah.
That's where images are supposed to form on the back of your eye. You've got a lens in the front of your eye, and for those of us who are nearsighted, these light rays are coming into that lens, and they're focusing at a spot that is too close, maybe right about here or something. So, in essence, your eyeball is too strong, and what has to be done is you have to have a lens to spread out those light rays a little bit more so that this image actually does focus on your retina. If you're farsighted, the opposite is true. Your eyes are too weak. So, it's not nearsighted people who can start fires with their glasses. It's farsighted people, because you would have glasses that bring light rays together before they get to your lens. And so then I'd say, does anybody in here have farsighted glasses? Does anybody have any? Like you can see things far away but not close up? Right here? Can I borrow your glasses? Thanks. Can you bring them up, actually? I'm kind of stuck. Thank you so much. So these glasses should have a different effect when the light rays are going through them. So, well, your vision's not too bad, is it? Huh. Okay, I'll give these back to you. Sorry. You can find your way. Yeah. So, if you have eyes that are really farsighted, you're going to have lenses that bring those light rays together much earlier. And so the prime example of that is a magnifying glass. Light rays would go through it, and instead of being spread around the outside, they'd be focused to like one certain point.
Whoa.
And so at that point, the smaller you can get that little piece of light, the hotter it's going to be in that location. It doesn't work for like light from this, but it would work for light from the sun. So that's what I would show you, and we'd start a fire, and it would be really fun. So we're going to have to save that for another time. Now, to understand this...
Try.
Well, it's not going to do anything, unfortunately. Take a look at worksheet number 5. We're going to transition from mirrors to lenses here. take a look at number 3 and number 4, please. So number 3 and 4 are essentially lenses. You've got one lens that looks like, sort of like this, in problem number 3, and you've got a lens that sort of looks like this in number 4. And as long as you got those light rays moving in the correct directions, that's exactly what's happening with these lenses. This is a converging lens. It would take light rays and bring them together, like number 3. This is a diverging lens. It would take those light rays and spread them out, like number 4. So that's the main thing I wanted to point out from worksheet number 5. That's why I didn't have you pass it in yesterday. But our introduction to lenses was actually doing numbers 3 and 4 on that worksheet. So if you could follow how the light rays move and why they behave that way with the car analogy, you're in really good shape. I'm going to come around and get that worksheet from you. Thank you. You're welcome.
I want some Culvers, dude.
Oh my gosh! Why did you say that?
They're like dying now.
I want food so bad, and you just made me think of a double bacon cheeseburger. Fries.
I'm gonna go get a quad stack burger. You know they have like triple cheeseburgers at Burger King?
Yeah.
My dad just made triple cheeseburgers. I had it once. I only ate
All right. I'm going to go ahead and pass out the next worksheet too, just to make sure I get it out there. This worksheet, and this is very important, this worksheet is your virtual day assignment on Monday. So you're just going to...
seniors?
What? Yeah, because you can do it before then. So all you do is you go through, you and then you snap a picture with your phone and upload it however you do that with the assignments thing on Schoology, and you'll be all set to go. If you have any issues with that, let me know. But I'm pretty sure all of your teachers have done that at one point or another, especially at the end of last year. So there is nothing else you need to do for Monday. Just submit that. If you want to do it tonight and have it finished, you're welcome to do that too.
Can we do it now? Or we
No. This is going to be something that you'll know how to do after our notes today. Speaking of your notes today, get out your notebooks, loosen up your hands. Let's go.
Oh no!
No, it's going to be kind of like the curved mirrors notes, only easier. If you want to label your notes, you could say lenses or something like that.
It is Salisbury State. Oh, why?
We should just get Culvers.
Yes. You should be able to leave campus.
Yes. Open campus. That'd be awesome. That's what it's called.
All right.
What do you think about that, Mr. Alford?
I think I'm going to talk about convex lenses right now. Personally, I don't care. When I was in high school, we had an open campus. So,
What?
I didn't go here though.
Well, yeah, I know. But
So,
what?
convex lens, would you say this is a converging or diverging lens? Yes. So this would be diverging then. And then before we figure out what's going on with the light rays with these, we got to actually make sure that I'm telling you the truth and not lying.
Are you?
You know, one of the fun things I say whenever people say, wow, you teach physics and AP physics? That's crazy. And I'm like, it's actually pretty easy because when you're the only one who knows how to do something, nobody can tell if you're doing it wrong. So, I want to make sure that you know that this is something that's real and true, that these light rays are actually being spread out and are being converged.
Oh yeah.
So,
It's about to be good.
I've got a converging lens, diverging lens, and we'll see what happens. And the fog machine is taking a break, but it'll be ready in probably 10-15 seconds, I hope.
Is the brakes out makes more fog?
What's it?
Does it like make more fog during the break or something?
It just, I guess it would overheat or something probably. Till it's ready, enjoy the darkness. Like Batman.
I will go to sleep.
I love dark.
Okay, here we go.
Do not.
Yeah, where's the on button?
Let's go.
There it is. Alright,
It's Christmas.
so you got your laser beams right here. First I'm going to do the diverging lens.
Oh.
So if you look close, you can see that it's taking these light rays and it's immediately spreading them out. They do not come together. They are spread out right away. And you can see the results on the wall. Dots of red that are spread out pretty good. Now the converging lens. In the same way that a converging mirror takes light rays and brings them together, converging lens is the exact same. Takes those light rays and it brings them together. You can see these are coming together right about here. Of course, after that, they spread out. That's just what happens.
Yeah, dude, that'd be sick.
Because then you can see all the lights in there and then
Alright. So here you can see pretty clearly these light rays coming together right about here before they spread out afterwards. So yes, point of the matter is I'm right. And that's usually the point. Okay. So, here's some good news. We are going to be taking some notes on why the light rays behave the way that they do and why you see what you see when you're looking through these lenses. And most often students say that with lenses it's a lot easier to follow and make sense of than when we did this same thing with mirrors. So hopefully that's true with you too. I'm going to go around and I am going to ask you to observe something far away with this convex lens. I'm just going to kind of walk by. Welcome back.
Thanks.
Don't ask questions. I'm going to walk by and just look through the lens at something far away. I kind of figured I probably shouldn't pass these out in case people aren't like sanitizing or doing all the healthy stuff.
That's alright.
So
It's okay.
it'll be in front of your face for just a couple seconds. Take a look at something in the distance. Take note of if it's upside down or right side up. Try and look like beyond me. You're trying to look at something that's far away.
Yeah, that part is
They're only at like 9.
Yes. Can you wait a couple minutes?
Yeah.
This is pretty important stuff here that we're going to be going through.
I can wait.
Whoa. There's
So are things upside down or right side up? They are upside down
and flipped.
and flipped. So we got to figure out why that is, and we have to explain it. because that's what we do in this class. So go ahead and draw a diagram with that type of lens. Whenever you draw these lenses, you want to put a straight line going from top to bottom on them. Furthermore, unlike mirrors that only have one reflective edge, these light rays can come in both sides. So you've got focal points on the left and the right. And just like you were looking at something distant through that lens, we've got an object that is relatively far away from this lens. Now, what do you suppose we're going to do with the first light ray that goes off the tip of this arrow?
It's gonna go down.
It's going to go parallel. Parallel is always the first thing we're going to do. So here it goes. Parallel light ray hits the lens. Where do you suppose it goes next?
Down.
It goes down, and your light ray will probably be more parallel than mine. Looks like mine's angling down a little bit. But yeah, it's going to go through the focal point. The same relationship that occurred with curved mirrors is present for these types of problems too. So that's one light ray. Where do you suppose I shoot the other one?
Oh, don't tell me.
Through the focal point.
Oh my goodness.
And what happens to that light ray, you suppose?
It's about to go up to the other phone.
Nope.
Oh.
Good guess.
Parallel.
Yes.
What?
Remember, the relationship is parallel focal point, parallel. So because this is going through the focal point, it's going to come out going parallel.
It looks like a square.
What does?
Yeah, it looks like a rhombus.
A rhombus.
Oh yeah.
And I'll continue this
What
light
is
ray
this
a little
geometry?
bit. Where these two light rays meet are where the image forms. Therefore, the image is going to form in this location.
It's gonna be upside down.
Sure will be. Again, you will not draw the image like this. The image always has to go towards the middle, towards this middle dotted line going through your lens.
Oh, shoot.
So it is upside down, just like all the images you saw as I was walking around with that lens. So, we're good so far. Questions on that? Is this real or virtual?
Real.
Real! 2 reasons. Number 1, it's upside down. Number 2, we've got actual real light rays coming together to make it up.
Oh, yeah.
Alright, now, I am going to walk around with the same lens, but instead of looking at something far away, you're going to look at my hand, which is much closer. Observe if it's bigger, smaller, upright, or inverted.
It's gonna be like Deadpool when he got his legs chopped off.
Whoa.
I don't want your peppers. I want like gushers.
Oh.
These gushers are
I'm
big.
gonna
They're
get
so
some
hot.
What?
What did you see? Is my hand bigger or smaller?
Very massive.
It is massive. Is it upright or upside down?
Upright.
It is upright. So somehow we have to figure out why it is that when an object is close to this type of a lens, we get an image that is upright and bigger. You guys are more polite than the other hour. The other hour was like, dude, your hand has so many calluses.
Why would they say that? Like,
Well, actually, I mean, you get calluses by doing manly work, so I mean, it's like, that's okay.
how do I have no
I am a man, last I checked. Okay, so now instead of having the object far away, we're going to have it nice and close, in front of the focal point. you'll probably be drawing this all over. So I'll give you a little bit of time here before we jump in.
It looks like a pea.
Keegan, you're so silly.
You're so silly too, man. You could be you could start a band and call ourselves the Silly Boys. Oh.
Oh my gosh.
What do you think?
No.
You guys are a hoot.
No, you're great.
Max, because I didn't play Red Dead with you one Friday in like June, and he's not making fake.
All right.
And then you killed my dog.
So what light ray am I going to send in first?
You guys play
The parallel one.
The parallel one.
I love those.
And what's that light ray going to do?
You bet.
Go
We
to the
can-
focal
we can
point.
squat
Yep.
up to posse up.
I've never played online.
Oh, dude.
I did the career.
I've just lassoed people and dragged them on the horse.
Okay. So we've got one light ray, and it's going parallel and through the focal point. Now this is where things get a little tricky. We are in front of this focal point. We are not on the other side of it. So I can't take a light ray and blast it down this way, because then it won't hit our lens. So what do we got to do instead?
From the bottom of it,
From the bottom of it? What do I got to do from the bottom?
go parallel.
Yeah, we got to go up from the focal point. So that's exactly what we have to do.
Oh, the Fox machine Spartan.
We take a light ray,
What?
and it ends
Oh,
up...
It just hit Bob up.
Listen up, guys. We take a light ray. It is coming up from the tip of the arrow as though it had originated from the focal point. This is the same thing we did with the curved mirrors. Because it's coming from the focal point, it will come out parallel,
Yes, I did do it.
like so. Now these light rays are never going to cross, so they're sad. Because they started in the same location, and they're never going to meet up again. So what do we do to make them a little bit happier? What's that? You got it. So we got these two light rays. They're moving away from each other. In order for them to meet up again, it's not going to happen over here. We got to take those light rays and follow them backwards, just like we did with the mirrors. So dotted line going back until they cross. And wherever they cross is where your image will form. In this case, we've got an image forming right here. It's right on the focal point. That's actually not going to happen in reality. Because just like with the lens, you're not going to have an image forming on the focal point in the same way it wouldn't do that with the mirror. But anyway, we've got an image that is right side up, and it is larger, and that's what we were predicting. So that's good. Questions on this one? Okay, one more example. So this is our diverging lens. Look at something kind of far away. Notice it's bigger, smaller, upside down, or right side up.
Keegan, why were you so comfortable? I said, why are you so comfortable singing that?
I don't know. The town of Wood.
Isn't that so?
Wow, that's small.
Not with me.
I don't hear it that much.
I hear it at work a lot.
Yeah.
Y'all better just be quiet.
Okay. What did you see? Bigger or smaller? Smaller. Right side up or upside down? Right side up. So we got to explain that with light rays. So let's do that.
Oh, more explaining.
Yep. This is the last light ray diagram.
You guys really crappy with that.
I did.
I hate the dentist.
Oh, I'm just excited that you have cavities.
Actually, I don't have. Right.
one thing I didn't mention when we were talking about the converging lenses, if you would have a lens like this, and if you have a light ray like coming from the focal point and it would go like this, in the same way that you were supposed to extend the mirror, you would extend the lens as well. So then it would hit here and come out parallel, if that's something that you would encounter on the homework. It is something you will encounter on the homework.
Good to know.
So make sure that you draw that lens upwards when you need to. Okay, what do you suppose we're going to do with the first light ray here?
Drop the flare level.
That's right. So here it comes. Here's your parallel light ray. Now, you say you hate parallel light rays?
Lines.
Oh, lines.
They're
Okay.
just so straight.
So this parallel light ray is going to hit this lens. Now, if this was a converging lens, it would go through and go down through the focal point. But this is not a converging lens. It's going to take that light ray and bend it up. How can I tell what angle it's going to bend up at?
From the backwards to the focal point.
Focal point, yeah. That relationship still holds. Parallel focal point. Even if it's not going to go through the focal point, in this case, it's going to be lined up with the focal point.
Isn't that something?
Next, I would send a light ray aimed at the focal point. Now, if I shot it through this focal point, it would go through this lens and it would bend it even more, because that's just what a diverging lens does. It takes light rays and it bends them apart. So I don't aim it at this focal point, I aim it at that one. Yep, because it's aimed at the focal point, it will hit the lens and come out going parallel.
Oh.
And you can probably see where this is going to go. We've got two light rays that are going away from each other. And anytime, you got it, anytime that happens, we take these refracted rays and we follow them backwards.
Probably do work stronger.
And they cross right in that location. So that is where your image is going to form. The image is upright and it is smaller, just like everything you saw through that lens that I just passed around. Questions on this?
Everything.
Incorrect. Need to be more specific. Okay. I got one more thing I want to show you, and then I'm going to take you through a little bit of the worksheet. But this is all just like the mirrors, except it's probably a little bit easier to digest because you're actually going through the lens instead of figuring out where it's going to bounce away. So, I've got a little basketball guy here, and he's going to be happy to show us something.
That's Tom Brady.
He plays basketball?
Yep.
Okay. So,
I don't know.
I've got
Yeah.
basketball player, and I've got my little lens here. Notice that if I get this in just the right spot, an image forms on the piece of paper. However,
Yo, that's crazy.
if I move my lens, or if I move my piece of paper, that image goes away and it gets all fuzzy. This is different from that pinhole camera activity we did.
Because there's a point of convergence.
Yeah, so here we've got a point of convergence. Everything needs to converge at just the right location for a lens to form an image. But for the pinhole reproduction, that piece of paper could be anywhere. The object will get brighter and dimmer, but it'll always be in focus. So that's a little bit of a difference there. The other thing I want to point out is, what do you suppose is going to happen if I cover up half of the lens? What's going to happen to the image on the piece of paper?
It's going to be waffly.
Maybe pretty small, maybe a little waffly. Can I get a volunteer to help me with this? Thank you. Come on up.
What am I doing?
You're going to hold this piece of paper over here.
Yeah, Andrew!
Thank you. So we've got our image. You can see it pretty clearly on the piece of paper there. Now I'm going to go ahead and I'm just going to take this, angle the piece of paper a little bit. Turn it this way, just a little. Other way. There we go. A little bit more the other way. That's good right there. So you can see, you can sort of see the image. Anyway.
You want me to be closer?
No, the distance shouldn't matter. That's fine. So you can see the image right there. If I cover up the top half of the lens, what happens to the image?
Nothing.
Nothing. It's still there. Might get a little bit dimmer,
What?
but the entire image is still there.
What if you cover up the whole thing?
What if I cover up the bottom too?
It's still there, gone.
It's still there. It's super dim. There's a little bit of an opening here. If I cover up the entire lens, it goes away. But as long as I have a small opening, you can just see it right now if you're looking. You can see the image clear as day right there. All you need. Thank you, Andrew. Give him a hand. All you need to form an image on a screen or a piece of paper is any tiny bit of the lens that you see right here. I could smash this lens on the ground, pick up one of those pieces and hold it, and you'd get that same image. It would be much dimmer because it's only one piece of the lens, but you're still going to get the entire image formation. Every single part of this lens contributes to the formation of the entire image.
It's like a team.
It is. That's a good way to put it. So let's take a look at the worksheet. We've got 5 minutes. I just want to show you a few things to get you started on it. What I just said is pretty much page 2. So you'll be able to do page 2 from the last 30 seconds of class here that we just went over. Number 1, this looks kind of like one of the questions on worksheet 4 where you have to draw a bunch of light rays from one spot. So for this one, all the light rays are going to come off the top of the bulb, and it says the top of the bulb focuses here. So what that means is all those light rays from the top of the bulb are going to pass through that location. You draw a light ray like that, because it's coming in parallel, it's going to go through that spot. If you draw a light ray that goes to the bottom of the lens, it will also pass through that location. And you can kind of do anything in between that. You just make sure that you do 5 light rays there. And of course your light rays should have nice little arrows on them too. Number 2, it's best to kind of draw this same thing for number 2 because that'll help you answer some of the questions on number 2. I'll give you just a second to finish drawing this and then I'll move the page up. So if I would just do the same thing for number 2, light rays coming from the top of the bulb, pass through this, pass through this location, and you could draw as many of them as you want in between. It says, what would you see on the screen? So what you would see on the screen is when it's here, the image is nice and in focus and beautiful. But in the same way that when I moved that piece of paper back and forth, that image got blurry, that's what would happen if you moved the screen back and forth here too. So however you want to word that is just fine. It's going to be blurry when it's not in this location. You can always watch this video too if you don't get it all written down. Letter B. In this respect, how are real images different from pinhole reproductions? Can anybody answer that? Remember what we said? How are real images like this different from the pinhole reproductions that we did for that pinhole activity?
It doesn't matter how far away it is.
You got it. So for the pinhole activity, doesn't matter how far away from the pinhole this screen is, you're going to get that image. It'll be brighter, it'll be dimmer, but it'll always be in focus. For this, where you've got a lens, it's going to be blurry. So real images are different from pinhole reproductions in that real images only form at one specific location. Real images only form in one specific location. Now number 3 says, suppose the screen was removed. Where could you position your eye to see the image? Let me show you something to get this answer. I'm going to try and angle this towards your face. Do you kind of see an image when you look through the magnifying glass?
Yeah.
Yes, you do. You see that image because your eyeball, put my arrows here, your eyeball is in this cone of light rays. You could position your eye anywhere in this cone of diverging light rays, and you're going to see that image. So that would be 3A. As long as your eyes are located there, you're going to see the image. And of course, letter B then says, so now using this, how are real images different from pinhole reproductions? Any guesses on how that would be answered? No problem. So for the pinhole reproductions, if you look through the little pinhole, you're not going to see the image. You're just going to see that color of light. But for real images like this, where you use a lens, as long as your eyes are somewhere inside that cone of diverging light rays, you still see that image. You don't need a screen for a real image. You do need a screen for the pinhole reproductions. So that's page 1. Again, this is due Monday for your virtual homework. I'll put something on Schoology for that. Have a good day. See you tomorrow.
So excited to go home.